Yeah, welcome back guys to Java lecture. Today we are going to be looking at lambda expressions, and we are going to look at the following topics under this lambda expressions. So the first thing we want to look at is to define what is a lambda. So if you can go on Google and do just a Google search, you'll find quite a decent number of definitions. So I've just put a summary of them here because majority of them are similar. So a lambda is a form of an anonymous class. We will see anonymous classes as we go on during the code demonstration. Then a lambda can also be defined as an anonymous method or an anonymous function. Some definitions say it's a block of code that gets input and returns something back. So these lambdas or lambda expressions brought what we call functional programming into Java. Before then, we only had imperative programming. But now we have functional programming, which comes with a whole lot of benefits. And then these lambdas were added in JDK 8. So in any programming language, a function has four things. You have to give a name of a function, the parameters. If a function receives parameters, you have to provide a body for that particular function, and even give a return type if that function returns something back. However, not all these properties are important for operation in our modern programming. For instance, the name of a function can be anonymous. Who cares about the name? And the return type also can be inferred. All those things. So now we see that when we remove these two seemingly unimportant parts, we are left with just two things. We removed the name, we removed the return type. We are just left with two things, the parameters and the body. And these two are ineluctable. In other words, they are unavoidable. Hence, a lambda expression has these two parts, a body and parameters. So what are the benefits that lambdas give? They remove a significant number of potential class files that gets generated when you are using a comparative style. We will see what we mean. This may not make sense now, but we will see what we mean by that. Also, we see performance, because if you don't have class file, there is nothing to load into memory. Loading time for anonymous class files and many other class files. We also see that there is less memory footprint, because if you don't have to load all those things we mentioned, it means that there is nothing to store, and obviously you have less memory footprints. And more the garbage, the objects to be garbage collected also are reduced. Then what are the guidelines to implementing lambdas? So lambda expressions, or a lambda expression, must be glue code. 2 lines may be too many. That's the guideline. A lambda must not be more than 2 lines. They say 2 lines may be too many. It's a recommendation. And you must just glue code together, and we'll see why that is important. Then why should a lambda be short? We see that code becomes extremely hard to read. If you have a lambda, you have lambda expression where the code is a lot of lines of code, it becomes too hard to follow or to read what that code is. Besides that, you find that you have code that is cluttered, uninviting, completely unattractive, especially if you are using lambdas maybe with streams, and then you have that chaining, where you're actually chaining, you are gluing lambdas in the chain. If you have code there, you don't have glue code, you may not even be able to read that particular that particular line of code, it will become completely uninviting. Then we see that if your lambda is not short, it can lead to duplication of code, where you find that one lambda has the same code as the other one. But if you have taken that code outside and include it into that particular expression, it becomes even easy for reuse. Then also we see that if a lambda is not short, it becomes difficult to test. In fact, we are told that lambda should not have logic. Logic must be moved into a function and have that function unit tested in isolation, and then you just include that function into your lambda expression. Then we have built-in lambdas. The built-in lambdas that ships with the JDK, we have the predicate, we have the consumer, we have function, we have supply. All of these are what we call functional interfaces. For you to be able to say you want to write a lambda expression, your interface must be functional. By functional, we mean it must only contain one abstract method in it. Then we know that it's functional. Then we have primitive lambdas. So with primitive lambdas, you have int lambdas, as we will see them in the code demonstration. We have long, double. We also have two lambda. So when I say two lambda, it means there is another name here. This is just a prefix for the name of the lambda. So if it's int, it can be int whatever, it can be long, double, it can be long something, double something. So it's just a prefix. So those are primitive lambdas. Then we have what we call binary lambdas, which is specializations of built-in lambdas. We have by predicate. We saw that the basic built-in, we have predicate, function, consumer, and supplier. We have by function, by consumer, just like that. Then we also have what we call binary operator, which inherits from by function, and it represents an operation upon two operands of the same type, producing the same type. So basically, you're talking of one thing where the input parameters and the return type are the same. Then you have a unary operator. Unary operator inherits from function, and it represents an operation on a single operand producing the same type. So the type and the return type is one thing. Then you also have some specialization of it. Int unary operator, double unary operator. The list is not exhaustive. Then you have what we call method reference. A method reference is a shorthand syntax for a lambda expression that contains just one method call. So what the method reference does, it makes the code simple and more readable than the lambda expression. So method reference refers to the method via the use of this operator that you see here, a colon operator. Then if you want to see more about lambda expression, I have written a very nice article where that is a bit in-depth, and the link will also be available on the description of this video, so that you can also read that article before you can go into the code demonstration. So these are the things we are going to demonstrate under the lambda. We are going to see that class file and anonymous class issues, and what lambda removes, how lambda expression solves that. We will look at the built-in lambdas and how to use them. We will look at the built-in lambda primitives. We will also look at built-in lambda binary operators. We will also look at built-in method we will also look at method references, our own custom ones, and we will also build our own custom lambda expressions.